Hello, in this example we are continuing our discussion of trigonometric integrals and strategy 2 with evaluating these integrals, which is to use Pythagorean identities along with a substitution. In the previous example, I described how we chose our substitution based on which function we had an extra function for, so that ended up meaning whichever one we had an odd function, an odd number of functions. So in this case we have an extra cosine because of the odd power. So this means that du needs to have cosine of x in it, possibly off by a sign, positive or negative. So then this means that u is going to need to be sine x. So we need to use cosine squared x equaling 1 minus sine squared x to rewrite everything else in terms of sine. So the integral from 0 to pi over 4 of sine squared 2 theta cosine cubed 2 theta d theta. First going to pull off an extra cosine. So we'll have the integral from 0 to pi over 4 of sine squared of 2 theta cosine squared of 2 theta times cosine of 2 theta d theta. Remember, we're pulling this off to be our du, so that we need to rewrite in terms of sine. Notice that this trig identity here is true for any angle x. So it's true even if x is equal to 2 theta, which is what we have here. So this means that we have the integral from 0 to pi over 4 of the sine squared of 2 theta times 1 minus sine squared of 2 theta times the cosine of 2 theta d theta. Now let's go ahead and pick our substitution. U is going to be the sine of 2 theta. Du is going to be 2 cosine of 2 theta d theta. We will divide both sides by the 2 to get a 1/2 du is equal to the cosine of 2 theta d theta, since that is what we have in our integral. This is equal to 1/2 du. Now, since we have a definite integral, we need to find new bounds as well. So when theta is equal to 0, u is going to equal to the sine of 0, which is equal to 0. And when theta is equal to pi over 4, u is equal to the sine of pi over 2, which is equal to 1. So now, coming back to our integral, we're going to have the integral from 0 to 1 of sine squared 2 theta is going to be u squared times 1 minus u squared times 1/2 du. So we'll pull the 1/2 out and also distribute inside of the integral. So we have 1/2 integral from 0 to 1 of u squared minus u to the 4th du. And now we have a couple easy antiderivatives. 1/3 u cubed minus 1/5 u to the 5th. This gets evaluated from 0 to 1. Very easy to substitute in there. I'll go ahead and distribute my 1/2 so that we get 1/6 times 1 cubed minus 1/10 times 1 to the 5th. And then both of our lower terms go to 0. So we end up with 1/6 minus 1/5. Sorry. 1/6 minus 1/10, which is the same thing as 1/15. So our final answer in this case is that the integral from 0 to pi over 4 of sine squared of 2 theta cosine cubed 2 theta d theta is equal to 1/15.